Sri Sai Ram. Today we are going to learn an interesting topic, domestic circuits. Before diving into this topic, let us rewind what we have studied in the last session. I have also given you some questions regarding the last session, so let us go and answer them. So the first question I have given is regarding electric generator. So what is electric generator? On what principle does it work? When a conductor is moving in a variable magnetic field, it produces a potential difference across its end and the current flows, right? That is the underlying principle in this electric generator. As you can see, north pole and south pole, you have what is the direction of the magnetic field? It goes from north to south. Now let us suppose we are rotating the coil in the clockwise direction. As you know, one segment of the coil is attached to one ring, which we call a slip ring, and that in turn attached to a brush which is attached to one end of the galvanometer. And the same thing, other end of the coil, it attached to another slip ring, and that is attached to a carbon brush which in turn attaches to another part of the galvanometer, right? Now let us rotate this coil. As we move AB towards up and CD towards down, what happens? What kind of current it produces? We can easily verify with the Fleming's right hand rule, right? So this thumb gives you the direction of the conductor, the motion of the conductor, and this gives you the direction of the magnetic field. Now this will give you the direction of the induced current. Now as I am moving this AB, this AB segment up, what I am doing? I am changing the direction of the conductor in the upward direction, and the direction of the magnetic field is from north to south. So the induced current will be from A to B, inside the board, A to B, right? The magnetic field is the same for CD also. It is going from north to south. But what is the difference? This CD segment which is attached to this slip ring is moving down. AB is moving up, CD is moving down. When the CD is moving down, that means the current which is induced in the segment CD will be exactly opposite to AB. It will be outward direction. You can again verify with the Fleming's right hand rule. The current direction, how it is moving, the segment CD, it is moving down. It is moving down means what? This thumb should go down. And the magnetic field is still the same from north to south. And this is at you. So the current is coming out of the board, and AB, it is going inside the board. Thus it is forming a closed loop. And then we can detect a current which is deflecting in one side. Now the key point is, suppose this is AB and this is CD segment. After it goes to a peak point, what happens? It has to come down. Now this CD segment, it has to go up, right? That means it is changing the direction. The magnetic field is still the same. The direction of the conductor is changing. That means the induced current direction will also change now. So if you attach a galvanometer to it, what happens? It will deflect in the other direction, because now the loop is becoming different. The current direction is becoming different. It is traveling from DCBA, because this conductor which is CD, it is coming up, and AB segment, it is going down. As it is changing the direction, the induced current is changing. So what we mean is, every half a cycle the direction of conductor is changing. For example, if you take this whole rotation as one cycle, every half a cycle, what happens? It has to go up, and after a half a cycle it has to go down. So every half a cycle it has to change the direction. Such current what we call as alternating current. So this generator with these slip rings, it helps us to generate alternating current. Now the second question which I have given you is, what is the difference between slip ring and split ring, right? A split ring commutator makes the current change direction every half rotation, whereas a slip ring commutator merely maintains a connection between the moving rotor and the stationary stator. That means the common thing between the slip ring and split ring is they act as intermediate source between the moving coil and the brush, right? You have a brush and you have a moving coil. These rings act as intermediate between them. Now, the split ring, what it does, every half a rotation, it helps the circuit to change its current. That means one end of the carbon brush is attached to always the coil which is moving up. Other end of the carbon brush is always attached to the coil that is moving down. Direction as far as this carbon brushes are same, right? It doesn't matter which segment of the coil is coming up, which segment of the coil is going down. It only sees whether the coil is coming up or coil is going down. If the coil is coming up, I am inducing this direction current. If the coil is going up, I will induce the current in this direction. So split ring helps in reversing the direction of the current. So with these two questions, we also kind of recapped all the topics which have discussed in the last session, right? Now let us go to the interesting topic which we discuss in this section, that is called domestic circuits. Before going to that, what we have studied in this chapter, we have studied a current carrying conductor can produce a magnetic field around it, right? And after that, we kind of winded up the coil and called it solenoid and connected it to a source of power and called it as solenoid, which also acts as electromagnet. After that, what we did, because of this current carrying conductor is producing magnetic field, and we put external magnet around that current carrying conductor and calculated the force on it experienced by the current carrying conductor, and that application we used in the electric motor. And then we have learned about the scientist Michael Faraday, who asked that curious question, if a moving charge can produce a magnetic field around it, why can't a moving magnetic field, changing magnetic field, can produce electric current? So we have cross-verified it. Yes, it is inducing a current, right? I am changing the current in the primary coil, the changing in the magnetic field is affecting the secondary coil, and it is inducing a current in the secondary coil. So which we call it as electromagnetic induction. Using that principle, we studied the electric motor. We applied that principle on generating electricity, and that equipment we call it as electric generator, right? Now we know how to produce electricity from any energy. We use that energy in rotating some turbines, so that we and put under a magnetic field, variable magnetic field. What happens? You are generating electricity. Now the thing is, we are producing electricity. How it is coming to our house, right? How we are using the electricity? You are producing so many amperes of electricity, so many volts of electricity. So how we are using in a house, how the electricity from the power plant is coming to our house? That is the main question. So let us dive into that question and let us know what all is happening around us in your house, in your circuits. So how they are working, you need to know, right? So let us go there. So you can see these long towers that transmit the power from the power station, right? So these wires, these long wires, carry high voltages with low currents. First of all, you can ask, why high voltage, low current? Why not high currents? Can my equipment which I am using in my home, can they run on high voltages? Why they are transferring high voltages with low current? Right? That's the question I also have. For that answer, you can have a half answer, that is to prevent the loss of energy. So if we transmit high current with low voltage, they are saying that you have an energy loss. So well, okay, but how? How you have that energy loss? Tell me clearly, clarify the concept. So for that you need to go to the previous chapter of electricity where you studied Joule's law of heating. So let us see how the passage of high current will have the loss of energy, right? We don't want that. So power transmission, power lost in a transmission is given by I square R. You studied in the last chapter. So if the power of transmission is I square R, what will be the energy lost in the transmission? If the charge is going in the wire, it is being transmitted in the form of, the power is transmitted in the form of I square R. If you have the current I in the transmitter and of a resistance R, the power lost will be the I square times R. That many times the power is losing. Okay, so the energy lost in the transmission in the given time, if you transmit that charge for an hour, that means 60 seconds. 60 seconds, that means I square R into 60 times. 60 times it is losing the energy outside. How it is losing energy outside? The first effect of the electricity is heating effect of the electricity, right? When the electrons pass through the conductor, it ruffles up the atoms around it and produces heat, right? If you pass more current, what happens? The charge flow will be more. The charge flow, the collision will be more. The collision with the atoms will be more. The heat will be produced and the heat will be dissipated around the environment. So the charge which the electron is carrying is, most of the charge is going out in the environment. It is not going to the substation. So how can this be useful? But I need to transfer power. I need to transfer power in such a way that I should prevent the energy loss. But if I transfer high current, the I square value is there. You can see the I square value. If you transmit 2 amperes of current, for 1 second it is losing out how many? 4 amps. 4 amps of current. So gradually it is going on losing the energy to dissipating the energy outside in the environment. I don't want that. So what we do, we also know the power is voltage times current. So let us use this. How do we use this? We need to make this power constant. We should not decrease this power. The same power I want to transmit, but somehow I want to decrease this, this value, I value. If I have to decrease this I value, which value I have to increase? I have to increase the voltage value, right? Reducing I and increasing voltage, keeping in mind that power as constant. Understood? So in this way I can keep the power constant. I can also transmit the power to large distances. How? I am decreasing, for example, power is 6. Okay. For example, power is 12. So V into I means what? You take 4 threes. Let us take 4 is volt, 3 is amps. 3 amps are more. So what I am doing is I am decreasing this amp to 1 and increasing to 12. So 12 ones are also 12. The power is constant there. Previously it was 4 threes. Now I decrease the 3 to 1 and increase the 4 to 12. 12 ones is, this power is constant, the same. It is for an example for your intuition, but this is how it works. So power transmission has to be done on high voltages and low current, right? Now you may ask, yes, you are transmitting high voltages, but I don't have that appliances in my home that can work, that can run on high voltages. So how does it possible to have low voltage to my home. I need just low voltage to my home, that only that voltages that my electrical appliances are capable of holding. I don't want so high voltages. There, what happens? Step down transformers come to the rescue. So this is coming, this is the wire that is coming from the tower. So what happens? You have these coils, and you have the secondary coil here. You have already studied in electromagnetic induction. What happens? Here, due to this change in magnetic field of this coil, it induces a current in secondary coil, right? So this electromagnetic induction phenomena we use here. The electricity, the high voltage power is coming here with 2 amps. This is for example. What is the power? V into Y, 2000 watt is the power. I have to have the same power on this side, right? But I need to have high current, relatively high current, and really comparatively low voltage. So what you do, we can play with this coil number of turns. You have 50 turns here, we have 10 turns here. If you want slightly more voltage or slightly less voltage, you can manipulate these turns to little high or little less to get the desired voltage and desired current. See here, 1000 voltage is decreased to 200 volt, and alternately what happened? 2 amps low current is increased to relatively high current, 10 amps. Still the 200 into 10, 2000 watts. So the power is not being lost, but we just played with voltages and currents using electromagnetic induction. So it works on the electromagnetic induction as we discussed. Now, if you have a direct current here, if you have a direct current in this coil, what happens? Does the direct current change the direction? It only goes in one direction. So if it goes in one direction, can the magnetic field change around the coil? It can't change. If it can't change, can it induce a current here? No, it can't induce a current here. So alternate current becomes very useful here. If you have an alternate current here, it changes its direction, thus changes its magnetic field, which influences this coil because it is around it in the vicinity of this magnetic field, and the induced current is generated here. Current potential difference and current is generated here. Understood? That's why alternate current becomes very useful. Okay, so we have a desired voltage value. In India, we use 220 volts for the domestic circuits, and the alternating current frequency is what? 50 hertz. 50 hertz means 100 times it. If you see alternating current, what it does, it reverses its direction, right? In India, it reverses its direction 100 times in 1 second. That means in one cycle it reverses 2 times. That means we have 50 hertz frequency of alternating current in India. So everything is fine. Now let us learn about the circuit system in our house. So 2 wires. You all see these 2 wires in your house. What are these 2 wires? One on red, comes in red color, one comes in black color. So what are their function? All right. So the colors are different. They two may be having different functions, right? What is this wire? This red wire we call as live wire. What this wire does? It carries the current of high voltages around 220, which is in India, to the appliances. Okay. It is the wire which is carrying current. It is the wire which is attached to the, for example, positive terminal of the station. It carries the current. Okay. If the high voltage difference between the neutral wire and live wire, this is called as neutral wire, this is called as live wire. The potential difference between these two is maintained 220 volts. If it carries 220 volts, what will be the potential of this wire? So neutral wire, black wire, completes the circuit by forming the path for the current back to the mains. It usually at 0 volts, hence the neutral wire completes the circuit. Neutral wire circuit, that means if you have an appliance, for example, if you have an appliance, the positive, this live wire goes into that appliance, this is our house, and comes back to the main through the black wire. Hence, the potential difference between the live wire and the neutral wire between the appliance is maintained 220 volts. So, in terms of the power station, in the view of power station, every house is an appliance. They are supplying 220 volts. In our house, there are many more appliances. For each appliance, we'll discuss it later how it is connected. So you can ask, sir, you are saying this is alternating current. So if the current is going like this is the house and coming back like this. If the current is alternating, the second cycle of how the current should go, it should go reverse, no? Right? Then does it becomes 220 volt? You are saying this is 220 volt, this is 0 volt. The potential difference between them is 220 minus 0. It is what? 220 volts. Now, when the current direction is reversing, does it become 220 volt? No, it does not become 220 volt. It remains 0, but this live wire goes down to the potential of minus 220 volt. So in turn, the potential difference between the live wire and neutral wire keeps constant 220 volt. Neutral wire is always at 0 volt. And this live wire fluctuates between 220 volt and minus 220 volt. Thus, in the alternating current, when it changes the direction, it keeps the potential difference same as 220. So that's what we stated. Hence, the potential difference of 220 are maintained between live wire and neutral wire. Right? So we have two wires, but you see, you have 3-pin plugs. Right? So why do we have that? Why 3-pin plug? If you see this, you can see this plug, right? This is, for suppose this is live wires connection, this is neutral wires connection. You can see this thick, long third plug. Why this plug is useful for us? Okay, let us open it. Let us see the back end of it. Oh, so this one is live wire, one is neutral, and third one it is telling the earth wire. So what does the earth wire do? Why it is there? So this is the fuse. We'll talk about it later. So our question is, what does this third wire do? Let us go and explore it. Earthing. For example, you have a metallic conductor. You have a washing machine or microwave oven. It is a metal body, right? So if the live wire somehow leaks the current on the metal body, what happens? Metal body is a conductor. So what happens? Some current will leak inside the conductor, leak on the conductor. If you by chance and go and touch it, what happens? You can see this. This is what happens. There is a live wire going and you touch this metallic body which is leaking onto this conductor. This live wire has some leak onto this conductor. What happens? The current goes through and goes to the earth. Because earth, we call it as a sink of the charges. So what happens? So you are providing a conducting path through you towards the earth. Why it is not going to the neutral wire? Because current always takes the low resistance path. Okay, where the resistance is low, there the current wants to travel. So you provide the current a low resistance path towards the earth. Thus you'll get a shock. How to avoid this? The main thing of earthing is to avoid this kind of damage to yourself. What happens here is, this appliance, there is an earth wire that is directly attached to the metallic body of this appliance that we see in the 3-pin plug. The green wire is earth wire that is attached directly to the appliance. If in case any leakage of current is going on the conductor, what happens? It goes directly inside the earth. The earth wire is connected in near your house and digged inside the ground, so that entire charge, the excess of charge, that leakage of charge which is going on the conductor will be passing through the earth wire and going inside the earth. Right? Why it is not passing through you? Why it is passing through the wire? Because we manufacture earth wire in such a way that it provides the low resistance than you. As we discussed, current goes in the direction of the low resistance, right? Where the low resistance is there, that path it will take. So earth wire offers low resistance than you. So it takes that direction, the excess of current will go inside the earth. So this is how the connection is made. So this wire equipment, if this is the equipment, the earth wire is directly attached to that equipment, and all the earth wires of our circuits, every switch has an earth wire. Okay, that all the earth wires will connect it to one wire, and they are digged inside the ground, so that any leakage of current will go inside the earth. Now you can see why the third pin is thicker and longer. It is thicker because you cannot mismatch with any live wire or Newton wire connection. If 3-pin plug is there, you cannot turn it and put the earth wire socket in the live wire. So that mismatch may happen. To avoid that, it is what? It is thicker. Why it is longer than the other 2 pins? Because you can see if you push it in the plug, the earth wire establishes the first connection before you establish the connection of the live wire and neutral wire. Thus, when the electricity is passing, if there is any leakage, soon it goes down to earth. And when you remove it, you can see the earth wire is the last wire to disconnect the connection. So in that way, it helps you from shocking, to prevent from shocking, electrical shock. So this is how the earthing works. The metallic body of electrical appliance is connected to the earth by means of earth wire. This is the earth wire. By means of earth wire, so that any leakage of electric current is transferred to the ground. And that is what we discussed. This prevents any electrical shock to the user. We use nowadays many metallic bodies. So you can also, this process is called as earthing, right? You can also ask, we also have 2-pin plugs, sir. Always we don't use 3-pin plug, right? So that equipment which is using 2-pin plug may leak the current, but not that harmful for us. The chargers, phone chargers, everything we use, that may leak current, but it is not that harmful for us. So that is not worth investing in the third earth wire. So when the current leakage is more, then that appliance we use the earth wire, right? Now let us go and explore how the circuit system in our house is made. All right, we call it as domestic circuit. About this earth wire we already studied. Every plug inside our house having earth wire. These all earth wire are attached to each other and they are placed inside the ground. Now these live wire and neutral wire are coming from the substation, coming from the transformer, step down transformer, which I have studied. It is having a potential difference of what? 220 volts. Okay. So it goes through for the safety precaution, we'll study about this in the later part of this session. This is electric fuse, and it goes through the electric meter, because electric board needs to know how much current you are drawing, right? And then it is going into the distribution box. In distribution box, it distributes the current into 2 circuits, right? Why 2 circuits? For example, if you want to draw the current for refrigerator, for geyser, for air coolers, they need more current. You can't use the same wire which you use for fans. For the air cooler, you can't use the same wire for the air cooler and for the fan, because fan does not need that much current, but air cooler draws more current. So we generally have what, two types of circuits. One is for high power rating circuits devices, and second is low power rating, relatively low power rating devices like bulbs, fans, etc. For high power rating devices, we use geysers, refrigerators, everything, because they want more current, their power is more. For example, if a heater is having 1000 watt power, right, we are supplying 220 volts. For example, let us take 200 volts. So it needs 5 amps of current. If any other device wants 2000 volts, 2000 wattage, if any device is having 2000 wattage, so how much current it want? It want 2000 by 200. How much? 10 amperes it wants. If you put that current, if you put that appliance to the circuit of 5 amps, what happens? It burns. Because it needs 10 amps, you are supplying 5 amps. It burns. So to bifurcate that, what we are doing, we are having 15 amps as one circuit for the heavy devices, 5 amps as another circuit. And all the circuits and all the appliances are connected in series or parallel. Just think about it. If you want to on a fan and I don't want a light, if those both are attached in a series connection, what happens? I cannot on the fan without switching on the light, because all the appliances in the series circuit are useful to be switched on, otherwise the circuit breaks, right? Hence, in the domestic circuit, every appliance we use a parallel connection. So parallel connection means it is if you want to switch on fan, you can just switch on fan. There is nothing to bother about light, whether you switch on or switch off. Every appliance will have the same potential difference, 220 volts. So hence we are using the parallel connection to have the independent usability, right? Now let us note the points what we have discussed in this domestic circuit. In order that each electrical appliance has equal potential difference, they are connected parallel to each other, right? Every appliance will have equal potential difference. If you are connecting in series, what happens? The potential difference drops gradually as we go to the neutral wire other end. So to ensure that every appliance should have potential difference, they are connected in parallel. So we discussed two separate circuits are used. 15 ampere current rating line is used to operate high power rating appliances like geysers, refrigerators and air coolers. We discussed about that. 15 amp current rating line means you have thick wire. When you have thick wire, you have the more charge flow, right? So this 15 ampere current rating line is used for those purposes. Second, 5 ampere current rating is used to operate relatively low power rating appliances like bulbs, fans and etc. which draws low current. We use them for 15 amp current line. In each separate circuit, different appliances can be connected across the live and neutral wire with separated switch to on off the flow of current. So what it is saying is, every appliance in your house is having a equal potential difference of 220, right? And they have a switch. They have the independence whether to flow the current or to switch off the flow of the current. So this is how our domestic circuit is manufactured. Now sometimes everything is fine. Sometimes you have excess of current. Overloading we call it. Overloading means what? Too much of current. Right? So what happens if you have too much of current? It is also called as one of the fault. It is known as, it is a fault in circuit system, right? If you have overload, there is some fault in the circuit system. Every wire has a certain capacity to withhold current. Like we saw in 15 amp line and 5 amp line. Those wires are different. Those wires have certain capacity to withhold current. Above that, they cannot hold the current. So if the current exceeds that value, wire heats up and insulation melts. You can see the red and black insulation on top of copper wires. Those are insulation. If you have more current, what happens? The heating effect. Too much current, too much heat. When you have more heat, the insulation melts. When the insulation melts, it may in touch with all the other wires and everything becomes so nasty. So what happens? Sometimes if the sudden you have more current, overloading is more, in the less duration of time, it dissipates more heat that can also catch fire. That is even more dangerous. So these are the effects of overloading. So what are the causes for the overloading? Too much voltage. Sometimes we have the lightning strike. Lightning strike means what? The charges are coming. Right? There is a bunch of potential difference between the earth and the atmosphere. So the lightning strikes in the circuit. What happens? You have the huge charge flow. When you have the huge charge flow, suddenly too much voltage comes. Right? And the second thing, what is the cause? Huge magnetic field comes in. You already studied. Right? If you have a changing magnetic field, the current is inducing. Right? If the huge magnetic field comes in, what happens? It induces a current suddenly in the wire. That is also cause of overloading. Connecting too many wires to a single socket, too many devices to a single socket. In these days we use extension box, right? So from one plug we take the socket and too many devices we attach to it. What happens? Too many devices draw so much current, but that plug is designed to draw, for example, 5 amps current. You have so many plugs. So each device, for example, 6 devices you have connected. Each device is drawing some current. So it is exceeding 5 amps. When it is exceeding 5 amps, the wire can't withstand, and it creates this kind of problems we have just discussed. Accidental hike in voltage supply from the power station. Sometimes accidentally it happens, the supply or the transformer fault, we will have suddenly high voltages. Now the third more important thing, the cause of overloading is when the live wire and neutral wire connected, then the current takes low resistance path which draws more and more current in the circuit. This is also known as short circuiting. What is short circuiting? When you have two wires melted or attached to each other, so instead of going through the appliance, for example, an appliance is there, microwave oven, okay, live wire, inside that live wire attached to the neutral wire, right? So this is the positive end of the wire, micro oven, and the neutral wire, live wire and neutral wire. By some fault, what happens inside the equipment, live wire is attached to the neutral wire. So what happens? It does not go through the equipment, because current always wants to follow the low resistance path. This wire, the wire we are using, melts and attached to each other. That means it is having very low resistance. The wire may have a low resistance. That means in 220 voltage, low resistance, hundreds of amps will be flowing through that. If the hundreds of amps are flowing through the wire, what happened you can imagine. You'll have a huge power loss and the circuit will break, right? So these are the causes of overloading and these are the effects of overloading. So we need to prevent that, right? So in order to prevent this, we have this ingenious instrument called fuse. What it does, you can see in the first diagram I have shown you that from the substation or transformer, this live wire and neutral wire are coming, and this main fuse is in series with the live wire. Okay, and you have separate fuses for separate circuits. 5 amp circuit you have separate fuse, 15 amp circuit you have separate fuse. What this fuse does is, if the current is passing through the wire exceeds the threshold value of 5 amps, this fuse has a connection here, right? That will melt. If that melts, what happens? It will break the circuit. When it breaks the circuit, current won't flow. When the current don't flow, it does not damage the appliance, right? It does not burn any appliance. So you have one main fuse here and also separate fuses for separate appliances, individual appliances. Every appliance has some threshold current that needs to drag. If the supply is more, what happens? In order to prevent the damage, they use an internal fuse. That fuse will burn. It will break the circuit. The current is not allowed inside the appliance. So it is safe now. You can change the fuse and you can again use as normal. Right? What are the properties of the fuse? You studied in the last chapter. The fuse should have high resistance. If it has high resistance, what has too much resistance? It heats up very fast. And in order to melt very fast, it should have low melting point. So these two are the characteristics of fuse. So briefly I have written in the points, the use of fuse prevents the electric circuit and appliance from possible damage by stopping the flow of unduly high electric currents, which you have studied. The fuse is connected in series to the live wire. Why live wire? Because this is only the reason from the positive end of the transformer it is carrying the current, right? So joule heating that takes place in the fuse melts it to break the electric current. Because if the excess current is there, what happens? Fuse is also designed to only allow that current, some threshold current. If it exceeds that threshold current, joule heating happens, it melts and it protects the circuit. It breaks the circuit and protects the appliance. Alright, with this we have completed this chapter, what is called magnetic effects of electric current. So we started with magnetic effects, how the current carrying conductor is behaving as a magnet and it is magnetic effects, and its applications which we saw in electric motor and in electric generator. Now we studied about how the electric circuit is being made in domestic, which is why you are seeing me, I am teaching you. That's how it works. So go through the entire chapter properly. Write down your notes by your own and have the concept very clear. In the next class, we will discuss about some important questions in this chapter. So before going to next class, let me give you some home assignment. What is overload? How does it happen? Very easy. Why do we use parallel connection in domestic circuits? We have already discussed what are the advantages of parallel and what is the disadvantage in having series connection. Why is it necessary to have earthing for metallic electrical appliances? This also we have discussed why is it very necessary, for example, for the metallic conductors, appliances. Why alternating current is useful in power transmission. So these are the 4 easy questions. I hope you have enjoyed this session. We'll meet next session, and until then, thank you. Sai Ram.